Hello, 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 hello. Good evening, everyone. Good day, and welcome to another episode of Javi. This is our second video for today. I hope you guys watch Ron's Kian video. And for this episode, we're gonna be talking about Laplace transform. Okay, so Laplace transform is a little different than the other topic. Right? Laplace transform is more of an application, okay? More of an application or of differential equation of mathematics into physical concepts. Okay? So I got so it's a topic discussed in differential equations, and more or less Laplace transform is a topic in differential equation that is uh, used mostly in processes, mostly in process flows, mostly in PID, okay, PIDs, and it's an application of differential equation, of integration and differentiation. Alright. So, anyways, let's continue. Okay. So basically, this one, I have a little image here. I hope you guys we got we made use of data and graphs and bar and images. Let's go. We're slowly improving. Okay, next time we're gonna have an image here. Okay, so Laplace transform is basically transforming your function of t's into function of s. But what does t and s stands for? No, we're not talking about x and y anymore. We're talking about t's and s. So t represents the time domain. Okay, so take note that most of our equations or most of our applications in differential equation right now are rates or changes with time, right? Velocity, acceleration, okay? Current, right? Ampere or current, right? That's a charge per time, okay? So we have Newton's law of cooling, temperature with respect to time, or growth and decay, substance with respect to time, right? So everything is a function of time, right? So basically, that equation dictates with the input time, okay, dictates your concept or your variable, okay. Now, for Laplace transform, the Laplace transform converts the function of time into S or frequency domain representation of the system or the signal. Okay, it transforms it to S. Okay, okay, and how do you transform those? Okay, so we have our symbol here. So this one, cursive, Laplace transform, bracket, f of t. Okay, and it will turn into function of s. But in order to turn that, we need to integrate our function of t, function with respect to time, dt, and multiplied it to e to the negative st while integrating it with the upper limit of infinity and 0 on the lower limit. Okay, so basically this is the basic formula for Laplace transform. Okay, okay, and I am an engineer. I'm an instructor in an engineering school. But I haven't introduced my. I am not willing to share my information or real life information to you guys. So I'm sorry. Wink, wink. But for engineers, or basically from my experience, okay, there is like, okay, I'm gonna be teaching the long method first. There's like two methods. I'm gonna be teaching the long method first, and the long method is this equation. Okay. Okay. So let's try on t squared. Okay. So let's say we have a function of t squared. Okay. If we're gonna transform that into a function of s, we could write that as just caps lock L. Function of t bracket or you can use Laplace t squared, right? T squared, integral of 0 to infinity e to the negative st t squared dt. Okay. Now that we have e to the negative st t squared, we can do let u is equal to t squared, du is equal to 2t dt, dt not d squared, right? dv is equal to e to the negative st, v is equal to e to the negative st dt, then e to the negative st over negative s, right? That's our v. Okay, so where we're using integration by parts, remember everyone, integration by parts is the integral of u dv is equal to uv minus v du. Okay, and that starts with uv is equal to v du plus u dv. Okay, that's the product rule. Starts us with product rule, and in order to get integration by parts, you move the v du to the left side. The differential of uv is equal to v du plus u dv. You move the v du to the left side. U dv is equal to differential of uv minus v du. Integrate both sides. Okay. And there we go. We have integration by parts. I shouldn't be teaching this to you guys, but it helps. I hope it helps. I'm teaching this, or I'm saying that with in mind that it helps you guys. Okay, so that's integration by parts. Integration by parts. Okay. uv minus v du. Okay, uv t squared e to the negative st over negative s, then minus v du e to the negative st over negative s t integral dt. 2 dt. I'm gonna put the 2 besides t. Okay, there we go. And that is equal to the Laplace transform of t squared. So it's not over yet. We still have to integrate it one more time. Okay. So 0 infinity t squared e to the negative st over negative s. Integrate this. This will become let's use let u again. All right. Let u1 t dt, t only, then du1 is equal to dt, dv1 is equal to e to the negative st dt, v1 is equal to e to the negative st over negative s. Okay, so before we integrate it, okay, I'm gonna take out the constant from these terms, mainly negative s and 2. I'm gonna take that out. So negative s and negative, so that's gonna become positive 2 over s, then uv t e to the negative st over negative s minus v du e to the negative st over negative s dt. Integrate. Okay, there we go. I'm gonna integrate this part too. Yeah. So 0 infinity t squared e to the negative st over negative s plus 2 e to the negative st over negative s squared minus e to the negative st 2 e to the negative st over s positive negative s cubed. Okay, there we go. So that is our Laplace transform without the upper and lower limit. That's without the upper and lower limit. we still have to like evaluate whether what is the value when we substitute the I'm sorry, the infinity and the zero. Okay. Alright, let's get started. Let's get started. Okay. So for infinity, if we substitute infinity on e to the negative st, okay, infinity, e raised to infinity, that's a very big number, or negative infinity, that's gonna be a very big number. And if you're dividing the value with e raised to infinity, okay, the upper limit will become 0. While the lower limit, this is the infinity, while the lower limit, 0 squared e to the negative s0, negative s plus 2 e to the negative s0. Oh, this one has t. We have a t here. There should be a t here. Okay. There should be a t here. Okay. Or 2t or 20. 20 e to the negative s0, negative s squared, plus 2e to the negative s0 over negative s cubed. Okay. The answer will now become, or your Laplace transform will be left. This will become 0. This will become 0. And what's left of your Laplace transform is 2 over s cubed. Okay. And that is the long method. Okay. That is the long method. Okay. We can make it shorter, actually. We can make it shorter. Okay. So, for example, I'm gonna skip the other two first. I'm gonna skip the other two first. For example, let's do t to the fourth. Oh, t to the fourth. Okay. Now, judging by our function, it's gonna be a long solution because, well, you know, t squared. It started from t squared t. You know, so we're gonna let cube a lot, you know, but we can do what you call it, shortcut. We can do not a shortcut, but actually a pattern recognition. E to the negative st, t to the fourth, dt. Okay. Take note, if we let u, okay, we partial integrate. If we partial integrate, especially functions, okay, especially the pattern of e to the a, then x to the n or x to the b. Okay, we pattern integrate. Okay, we notice a pattern. We notice a pattern. This one, t squared, t, 0. Okay, so we could say that our integrated part will become t to the fourth, t cubed, plus t squared, plus t, plus, there's no more t, constant, right? This will become 4. This will become 12. This will become 24. Okay. 24, and this will become just 24 because you cannot differentiate it. So basically, this become t, 2t, and they become 2. You differentiate each term. Okay. And it's multiplied to the same, e to the negative st, 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 e to the negative st. Okay? Plus, 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 plus. Okay? That's 5 terms. Right? Divided by, see the pattern here, negative s squared, negative s cubed. Right? Negative s squared, negative s cubed, negative s to the fourth, negative s to the fifth. Okay, negative s to the fifth. Okay, and if we substitute the upper limit to the lower limit, you will have values with the upper limit 0, 0, 0, 0, 0 for the infinity. Then for the lower limit, because there's t to the fourth, t cubed, t squared, everything with t, they should have t. Everything with the variable t, or every term with a variable 3 will have 0. And what's left is gonna be 24 e to the negative s0, which is 1, minus or positive s to the fifth. Okay, or the Laplace transform of t to the fourth is is 4 factorial over s 4 plus 1, or that's 4 times 3, 12 times 2, 24, 24 over s to the fifth. Okay, that's the Laplace transform. Okay, that's the long that's a semi long method. Basically, you still derive its or integrated its function, but there's a pattern to its function or integration by parts. Okay, whenever there's e to the ax, e to the a, and x to the b, so basically the pattern will become the integral of e to the ax, e to the a and x to the b will become dx e to the a over a, okay, the plus d squared x e to the a over a squared, right? There will be a pattern like that, negative and negative. No, it depends. Okay, it depends, positive and positive. Okay. Okay. I hope you guys. I still recommend. Like doing it manually, because this is not a guaranteed pattern. I basically just notice it. We basically just like assume from the given. We could be wrong, but there's a pattern in it. Okay? And as always, I always tell my students, whenever you see a pattern, you're going on the right track. Okay, having a pattern doesn't mean you have to follow it. Having a pattern means that you're knowing that you're going on the right track. Okay, don't follow a pattern because no, don't do a solution by following a pattern. Just that should be wrong. Do a solution and check by using a pattern. Okay, because a pattern can be proof that you're doing the right thing, but I don't recommend like using it for you to have the right answer. Okay, it could be wrong. You don't know. Always do. Well, I recommend the long method. Okay, but when times are rough, you can use the pattern. Anyways, let's do cosine t. Let's do cosine t. Okay. Function Laplace transform of cosine t. Okay, let's add a different value. Let's say 5t. Cosine 5t. Okay, cosine 5t. If we integrate that 0 to infinity. Okay, e to the negative st cosine 5t. Okay, so if we integrate that, we cannot use the pattern. It's a different value or a different function. Cosine and x are different variables. So first, let's integrate cosine 5t. Product rule. Let u is equal to cosine 5t du is equal to sine 5, differential negative sine 5 sine 5t dt. Then dv is equal to e to the negative st dt. V is equal to e to the negative st over negative s. Okay, so we're gonna have an integral of, the integral of the e to the negative st cosine 5t is gonna be cosine 5t e to the negative st over negative s. I guess it's the same pattern. I guess you could use that probably, because it's the t to the fifth, right? It's the same pattern, I guess, but let's see. E to the negative st over negative s du is negative 5 sine 5t. Oh, it's not the same because we're tackling with we're handling sine. Okay? So cosine 5t e to the negative st over negative s, positive negative 5 over s, integral of e to the negative st sine 5t dt. Okay, let's do it again. Let's do it again. Let u1. Okay, u1 is equal to sine 5t. I'm seeing a very bad pattern here. Well, let's see. Cosine 5t dt 5. dv is equal to e to the negative st over dt. No, not yet. V is equal to e to the negative st over negative s. There we go. There we go. Why am I making that sounds? I don't know, but I think we're close. Okay. So negative 5 over s parentheses sine 5t e to the negative st over negative s minus v du e to the negative st over negative s 5 cosine 5t. Okay? Integral. Okay. Now, we're having a bit of a problem here. Okay. Notice we have cosine 5t e to the negative st over negative s. Then we have now 5 over s sine 5t e to the negative st. This is gonna be negative s squared. Okay. Then this will become negative 5 squared. Oh, positive now. S squared. S cubed. Oh, negative. Okay, negative. Then e to the negative st cosine 5t. Okay. Okay. So we have now e to the negative st cosine 5t. Okay. Wait. Let's take note. Okay. That's the same of our initial value. Okay. So meaning the integral is the integral of e to the negative st cosine 5t is equal to this value. We can now manipulate. I'm gonna move this to the opposite side. So this will become e to the negative st cosine 5t integral positive 5 square over s cube. Wait, is that s cube? No, we haven't integrated this yet. So this is gonna be s squared. Okay, we haven't integrated this yet. So that's only s squared. Okay, s squared. Then what do we do? This is negative, so that's positive, right? So that's positive, and this needs to be negative. Okay. Okay. So whenever I do I do an alteration, I double check my sign. Okay, because especially integration, differentiation, signs are the negative and positive sign. They are the most cause of error. They are the most error I've seen in my students, and I'm not an exemption to that kind of error. Usually I made mistake on the signs too, on the positive and negative, so I always double check it just for good measure. Okay, so 5 over s squared sine 5t e to the negative st. Okay, and these have the upper limit of infinity and 0. Okay, manipulate this equation. We will have e to the st cosine 5t, then 1 minus 5 square over sine square. Okay, that's basically it. Okay, now if we evaluate this equation, having e to the st, infinity will basically, your upper limit becomes 0, while your lower limit, your lower limit 0. Cosine 5 times 0 is 1, right? And sine 5 times 0 is 0. Okay, so basically your cosine will have a value which is negative 1 over s plus 0. Okay, so now we can divide both sides by s squared minus 5 squared over s squared. So this will become e to the negative st cosine 5t is equal to s over what's that? Yeah, s squared over s squared minus 5 squared. Is that it? I think that's it. Yeah, there we go. Oh, lower limit. This is positive, okay? Lower limit. Yeah, this may be negative, but because 0 is lower limit, so that will become 0. So s squared or s over s squared plus minus 25. Minus 25. And that is the Laplace transform of cosine 5t. Or in formula, it's s over s squared minus a squared. Okay, which is, that's the Laplace transform of cosine ax. Okay, I hope you guys learned something, So at first I was like, I didn't know you can transpose a right term into the left term, but it makes sense, if it's the same as the given, and if we continue this integration, we're gonna have like an infinite value of terms, because cosine will become sine will become cosine, and cosine will become sine, and it's gonna loop around, right? So in order to stop the value from there, we can move this term to the right term, right? And basically get the difference, or the difference between the first term and the last term, considering that we already integrated the e to the negative st trigonometric function something t, right? Okay, and that's a very amazing thing, Okay, so this is gonna be my first, right? This is gonna be my first. So I have an example here. Ft is equal to sine squared t. As a challenge for you guys, I want you guys to, I want you guys to a challenge, or as an assignment, maybe an assignment to you guys. I want you guys to do this at home, or at your desktop, at your laptop, at your mobile, determine its Laplace transform, okay? Determine its Laplace transform. It will be fun if you guys try it, considering this is cosine t. I'm gonna give you guys a hint, wink wink. You can have a manipulation first. You can transform it by using double or half angle identities. I hope you guys are excited to do this kind of problem. Good luck. And this is basically the long method of Laplace transform. Okay, this is basically the long method of Laplace transform. But what is the short method, or what is the shortcut method? Okay, so basically, if you guys search on the internet of Laplace transform, there's like Laplace transform is okay, the Laplace transform of values, for example, let's say t to the 9 as a formula. It will become 9 factorial over s to the 10, or basically, let's say the Laplace transform of t to the n value will become n factorial over s to the n plus 1. Okay, so there's formulas for every types of Laplace. Okay, and the long method is basically the manual way. Okay, the long method is the manual way, and for my students, I'm gonna require them to do the manual way. Okay, but if we're talking about let's say t to the 5th plus t to the 4th, we're talking about polynomials. Okay, we're talking about polynomials of Laplace transform. Okay, I'm not gonna require them to do the long method. That's I'm sorry, YouTube. That's too long, right? That's too long for a long method. That's too long, right? Okay, so we're gonna be if we're talking about Laplace transform of polynomials, I'm not gonna require them the long method. Okay, I'm not gonna require them. Okay. Oh, not T. You know, I'm actually like new to Laplace transform. So if I'm wrong and if my integration or differentiation, please tell me. Okay? I'm not very comfortable yet. Okay, so 5 times 4 is 20, times 3 is 60, times 2 is 120 over s to the 6. So 2 times 4 is 8, times 3 is 6, times 2 no, 24, times 3 is 24. 8 times 3 is 24, times 2 is 48. 48 s to the 5th. Plus 3 times 3 is 9, times 2 is 18 over s to the 4th. Okay, that's the Laplace transform of this equation. Okay, and that's the shortcut method. Okay, I hope you guys learned something, and thank you so much for watching the video. And this is your teacher. This is your teacher, Jappy, speaking, and I just want to say thank you so much for watching the video. I hope you guys learned something. I'm repeating myself. Goodbye. Bye-bye. See you guys for more. Bye-bye.